Welcome back, tubers. So the time has come to upgrade our 18650 charger that's been up on the wall for the last couple of years in the garage. It's charged thousands upon thousands of cells. It's looking really old and tacky now, and we really need to renew this, make it bigger, make it better, and let's just do that. Let's roll the new build video. So tubers, let's get into it. What I've currently got here is a TP4056. These are cheap as chips, and this is what most people use to charge 18650 cells. One of these and a cell holder. All you do is just wire it onto the chip, and just like I've done with my other design. The biggest problem with that, whether you use a single cell holder or you use a set of 4 cell holders, the biggest problem with this is the fact that the wires start to get quite messy, and there really needs to be a better design or a better way of doing it. So what I've done is I thought, well, I need to increase the capacity of how many cells that I'm charging all at once, as well as the fact that my current boards and wires are just looking really messy, and it's lasted really well for the last 2.5 years, and it's charged thousands of cells. However, it's looking really old and tacky, so we really needed to come up with a better solution. I had a look on the DIY Powerwall group on Facebook, and if you're not a member of that, obviously join. If you're really into 18650 cells or anything like this, then definitely join that group. But on that group, what I found was someone created a PCB. So I thought, hey, let's just print it and see how it goes. So I went over to JLC PCB, and these guys were great. All I did was I downloaded the file from the DIY Powerwall's Facebook group, and it just downloaded it, and then I dragged it across to their website and pretty much just hit create order, and 3 or 4 days later it arrived all the way over to New Zealand. So fantastic, guys, really quite simple, and yeah, it came within a very short amount of time. This is how it comes packed. So you've got your nice little pen there that you see on quite a few YouTube videos, as well as what I've just printed. So this is what I found from a guy called Philipp. So he created the design for this PCB, and I'll just bring this closer up to the camera so it might be easier for you guys to see. What we've got here is we've got space for 4 TP4056s, as well as a 4-way cell holder. So how that works is you place the 4-way cell holder on top, and then you put in 4 different TP4056s along the top. And that way you don't have all those messy cables that I've currently got, or you don't have to somehow cable manage them to make it look nice and neat and tidy. So just by printing these PCBs, it just makes it so simple. Just put your cell holder on top, put your TP4056s on, soldered on, and apply power to it, and then away you go. So just looking at this in a little bit more detail, we've got our, I'm not too sure how well this is showing up with the light, but we've got our 4 charging boards along the top. We've got our power in, our positive and negative. We've got spaces for 4 different fuses, and I'll put probably 2 amp fuses in here, and these are just glass fuses that you can use. If you don't want to use fuses, and unfortunately you have to on this board because of the way it's been connected, you have to put a fuse in place. So I'm not really, I don't think you need a fuse on a charging board, because the charging board will just blow rather than a fuse, but because these charging boards have no protection on them. But either way, we might as well put some fuses on here anyway, because we've got, well, I've got them, and we might as well use them. But one thing I'd like to see on revision 2 of this board is you can see that there's this track that goes along the top here that goes to the next one. What you'll see is if I bring up another board and put them side by side, the design is obviously so that you can connect multiples together and that you can join them together. However, the problem with this, and I'm not sure if the light's going to be good, but the problem with this is that the top track is not going to be enough to run. So just quickly, 4 of these is about 4 amps. If you put another board side by side, you now have to put 8 amps through this track. That's probably going to be a little bit too much for that track. So if I flip this over, you'll see on the back he's used a really thick track that runs along the back here, for one of them, which is actually the minus, which is the positive. However, the negative has this much thinner track. So I'd like to see in revision 2 that this wording that he's put here for TP4056 actually gets moved down to create more space for a larger track to run along the top. So that's only a problem if you're obviously connecting multiple of these. However, today what we're going to do to get around that issue is we're going to just, rather than applying power at one end, what we're going to do is apply power at one end, halfway through and along as we go. So what we're going to end up doing is putting this single one aside, and what we're going to do is we're going to put, because I want to use all 10 of these, what I want to do is move them across. I want to have 5 there, and I'd like to have the other 5, if I move that charging board away, the other 5 along the top. And we can get rid of that now. And what we do there now is that we have a nice surface to put all our things on. And one thing about this, obviously, again, is that it tidies everything up and it makes it look much cleaner. Now, obviously, what you can't do is just put positive and negative along the top on one side here and expect the power to go all the way through down to here. There's just too much current, because each of these is 4 amps, so 4, 8, 16, you get the point. So it's a lot of current to go through a very thin track. So what we need to do is put power potentially here, put power here, put power here, just so that all the load isn't going through one set of tracks or towards the end of either side. Even putting positive and negative on each side, I think there might be an issue with the voltage drop along the end here. But either way, most of you might just be using one of them or using 2 of them side by side, in which case it's going to be fine. For me, I'm going to be doing all 10, so it just complicates things very slightly. And what I want to do is try and keep it on this nice piece of wood that I've got here. And this will look much nicer on the wall than my existing one. Obviously, to power all this, these are all 5 volts. One thing I'll mention very quickly is that even though this says protected 18650 board, it's only protected by fuses. It doesn't help at all, really, because the charging circuits have no protection on them at all. And what that means is that as soon as you put your cell in the wrong way, the charging board blows. So you need to make very sure, just like if you were to do it the traditional way, which is to use a cell holder and a TP4056, is to make sure you put your cells in the correct orientation, otherwise you end up blowing the boards. That's not too much of an issue because these are as cheap as chips. However, it's a pain to desolder them, the 4 wires, and to solder a new one on. It's obviously going to be slightly more of a pain once we put them all on to the circuit boards, and it's just going to be quite frustrating to then obviously desolder them and solder new ones on. But we might have to give it a go, because I'm sure that's bound to happen. At some point I will stick it in the wrong way. So either way, I'm going to have 40 of these, and really what we need to do now is look at what we need to accomplish this or build to create this build. We've got all our PCBs. Next thing what we need is we need all our cell holders. So I've got 10 of these as well, all ready to go. The other thing that we need to have is a power supply. Now this is an old server power supply that I've had for years. It's just been sitting around, and one thing that is good about this power supply is that it will do 5 volts at 33 amps. Now unfortunately, some of you might have noticed that if each of these is 1 amp and there's 40 of them, I'm going to need a minimum of 40 amps to be able to charge all these 40 cells. To do that, however, the simplest way I thought about doing that is, rather than replacing the power supply and trying to find another power supply, I thought, well, I could do 30 amps on 5 volts, so pretty much all of these on 5 volts, and then because the power supply can't do any more on 5 volts, what I'll do is I'll use, if I lean across, I'll use a buck converter. So that way I can put 12 volts in here and then get 5 volts out. All these need 5 volts. So I'll put 12 volts in, I'll get 5 volts out, and this will be enough to run a couple of boards. And that'll get me over the edge for supporting all 40 cells on this power supply. I obviously could find another power supply that could potentially do it, but might as well use the one I've got, and this is only a few dollars, so hey, let's see if it actually works. So we're going to be using both these things, our power supply, our buck converter, 12 down to 5, and we're going to wire this up. What I've thought about doing is I'll bring these down on the board here, and I'll move these ones down as well, and then I'll move this up a bit higher, and what I'll end up doing is I'll cut a hole here, and we'll throw all these cables through the back, because when we put it on the wall, it doesn't have to sit flush on the wall, it's going to sit just off the wall. So I thought it'd be a good idea to do that. So what I'll do is, really the next step is to kind of get started on marking where we're going to put these on our piece of wood. So what I've done now is I've marked out where all the PCBs are going to sit along here. I've also printed out some brackets, 3D printed some brackets, which will hold the power supply in place. It's got an indented screw hole that works quite well, I think. We'll try and get that on camera. I'm not too sure how well that's going to show up, but you can see the hole there. And what I'll do is, this power supply already has a bracket at the bottom here, so rather than printing 4 of these, I only need to print 2 of them, because the bottom 2 I'll use as the mounting. So I've got my hole drilled. I want to put this up here somewhere. I want to attach these 2 brackets on the top parts of the power supply, something like that, and that's going to hold the power supply. 2 screws at the top, 2 screws at the bottom, and that thing's not going to move, and it's nice and accessible. Right, so power supply is in place, and that's holding quite nicely, and it's not going to wiggle around. So the next thing to do is to push all these cables back through this hole. Right, so now all the cables are through to the other side without damaging the table. Next thing to do is we need to drill out the holes that the cables are going to come through, so that we can put our PCBs on top, and that the way all the cables are behind. So what I've done is I've just drilled all my holes, and I've just now cutting up some 25 amp wire, and what this is going to be used for, I'm just stripping it on each end just to make this next part a bit easier. So what I'm going to do is I'm going to do these last 2. So what's going to happen is I'm going to have my PCB board. Every couple of them is going to have the wire connected to the back, and then what it's going to do is it's going to be connected to the back, soldered here, and then it's going to feed through the hole towards the back. So that's why these wires are going to be quite short, and they're just going to go through to the back of this, which is where we're going to wire it. So what I've done now is I've soldered on the positive and negatives on each side. They were actually quite difficult to solder because the wires were so thick. So I've done this now to 6 of them, and now it's just a matter of flipping them over and feeding them through the holes that has been created. I've made a bit of a mess here, but that's okay because it's actually going to be covered. So I want to do that, and then we'll move on to the next part. Next thing we're going to do is put in our fuses. These are the fuses I've got here. These are 2 amp fuses, and just glass fuses that I got quite a while ago, and I'm just going to use these, and I'm going to connect those in. So 4 of these for each of the PCBs. So I'm just going to put them in there like that, wherever that is on the camera, and I'm going to do that for the rest. So now that all the fuses are in place, I've soldered those in there. Next thing to do is to attach our 4-cell holder of 18650s in place and solder that on all 8 of these. So I'm just going to continue and do that. So the next thing to do is to wire up the power supply to each of the PCBs. So I thought what I'd use is some of this nickel strip that I've got, that I've used for wiring up my 18650s. And what that'll do is it'll create a bus bar at the bottom for the negative, and then the positive, which will go along here. And it just means that I can connect all these these power cables, these 5-volt ones, along here, and some of them along here, and it makes it much easier for the shorter ones to connect through to the tops of here, because that's as far as they will reach without having to kind of link between each of these positives. That might make it a little bit easier if I just use this nickel strip to do it. And obviously again with the negative or the blacks, to put that along the bottom here and up on this middle one here. This end one, I've left that free because this is where I'm going to connect the 12 volt buck converter down to 5 volts. This needs to run separately. So that's going to run off a couple of 12 volt connections to the buck converter, and then from the buck converter back to 5 volts. So that'll run off, yeah, a couple of these and sit somewhere over here. Not too sure how to attach this yet because there's no screw holes or anything to attach that to the wood, but maybe that's probably the neatest way to do it. So this is how it's now looking. So we've got all the blacks connected, we've got the reds connected. So we've got 5 volts coming to these ones down here, and we've got the 5 volts coming up to here. So I've left these ones here alone. I'll just leave those aside for now. I've just wrapped this in some tape for now. And the other thing I thought I'd do is, while this is quite sturdy on here, it's got a bit of movement, and I was thinking that if for whatever reason, if the solder heated up or if they got warm, I just didn't want them to move. So what I thought I'd do is I'd bring out the 3D printer and print some clips to hold these things down. So what I did was I did exactly that. So I printed a whole bunch of these, and I'm not too sure how well you'll be able to see them. I just kind of drew them up. Now these will I might be able to zoom that in for you actually. That would be handy, wouldn't it? So yeah, they're just a whole bunch of clips with the indented part. Now I actually made the indent 2.5 mil without actually double checking the actual thickness of the nickel strip, and yeah, it potentially only needed to be 1 and a bit mil. So well, either way, what will happen if I zoom you back out again, what will happen is that these I'll mount along the bottom here, and the screw is obviously indented to try and keep that as tidy as possible, and that'll just hold the bottom nickel strip, or the nickel strip in general, just so that if it gets bumped or knocked when moving it around, it's not going to rip off the solder joints. So what I want to do is I'm going to just do something like this, and then just screw all those down. Right guys, so that's all clipped in, all the screws are in place, and that actually looks really tidy now, so that's quite a good improvement. So I've spent so much time doing the other side, I've actually almost forgotten what this side looks like, and it's nice and clean, got some nice space up here. Potentially I can add some more, but now the thing to do is that we've got our positive and our negative coming in here and over here, and the same again at the top. And now what we need to do is we need to connect them together, because only every second one is actually connected to the back. So what I'm planning to do for that is to grab some more nickel strip and just cut it into small pieces like this. And then what I'll do is I'll just use the nickel strip. Of course you can just use wire if you've got wire, but I've got a lot of nickel strip, so I was planning to just put these in here and then just solder them in place. Now I've just done a couple of these, and I'm actually running a bit low on solder, and I went up the road just quickly and grabbed some new solder. This stuff here is just the 6040 with lead, and it's obviously not it's not the best, even though it's the cheapest, but it's potentially not the best. This stuff here, this is 500 grams of it, and it's a heck of a lot more expensive. So this is about $70 New Zealand. and it is 99.3 tin and 0.7 copper. So it's about 3 times the price, but I thought I'd give it a whirl actually. It was cheaper to buy it in a 500 gram one rather than just a 250, and it's meant to have potentially less fumes, and it's obviously far better for you because it doesn't contain any lead. Right guys, moment of truth. So what we're going to do now is we've connected all our interconnects. The next thing to do is make sure we've got 5 volts where we need to, and the positive and negative are the correct way around before we go and connect all these 40 charging boards, because the last thing that we want to do is have it wrong and then end up blowing up 40 of these all at once and then having to desolder them. So what we're going to use is our multimeter, and we're just going to go through each of these and just double check we've got 5 volts on the inputs, and we're good to move on to the next part, which is to solder these in. So I've just connected this on, moment of truth, because that way the camera's on if anything blows up. So let's turn that on. Okay, so far so good. Bit of hum. Okay, so now we'll just test out our 5.2. Come over to here. That's nothing. That's good, because this is going to be connected to our buck converter. So these 8 cells aren't connected to the main power supply right now. So 5.2. 5.27, that's good. 5.27. 1.27, perfect. Okay, so we're really good to go with next step, which is soldering these things in. Right, so the time has come to connect in our TP4056s. Now to do this, what I'm going to do is try and make it as easy as possible, and I'm going to use some solder paste. Solder paste is absolutely amazing. I've only used it a few times now, but pretty much what you do is it's just a paste. So you paste it on to where you want the solder to be. And today I'll bring that into the thing. So what I'm going to do is today I'm going to use a straw. I want to give this a go. That I've cut the end off. And what that's going to do is allow me to hopefully easily apply the paste. So the idea is to not use a heck of a lot of it. And pretty much what I'm going to do is I'm going to put the paste everywhere I want the solder to be. And what I'm going to do is, for example, I'm going to put the paste on all the 4 corners. So, but there, and I'm not too sure how well this is going to work, but we'll give it a go. So you don't need a heck of a lot of it because it works really well. What it does is when you apply heat to it, it will solder whatever you need, the 2 surfaces together. So it's quite good. So all I'm going to do, in fact what I might just do now, is I'll apply this paste and then to these 4 here. And I will attempt to get these 4 done all at the same time, and then we'll obviously replicate that. Whoopsie daisy. Replicate that with all the rest. Because doing this with the camera going is just a little bit more difficult than it would be otherwise. It's a bit hard to see without sticking my head in the camera. Now, when I've got this, I ended up buying quite a few of them. I've got about 4 pots of this. So it's way more than I would need definitely for this project. because you don't need much at all. Now it's a bit hard for me to see, but hopefully but you've probably got a better view on the camera. Put the lid back on. You do need to keep putting the lid back on because it does dry up. I'll put the straw away. And the next thing to do is just to lay our charging circuits directly on top of that without wiggling it around too much. Now I'm going to put all 4 on at the same time. Just because, well, let's just try and be confident that this is going to work. Now, what you'd normally use to heat the solder paste, just give it a small bit of a wiggle. Those look like they're properly aligned. Push them down. Yeah, so what you'd normally use to melt the solder paste is one of those heat ones that come on some of the expensive soldering irons. Obviously you can use a heat gun, but that's going to be way too big for what we need here. So all I'm going to do is I'm just going to use my soldering iron that's extremely hot, and I'm just going to put my finger on this and just heat one side of it, because the heat should flow through to the bottom there. And now that's stuck. So that's pretty much all you need to do. You can see a bit of steam that comes off it. Ooh. So I'll just do this for all 4 of these. Oopsie daisy. And put your finger on it so it doesn't wiggle around. Now, of course, while trying to do this on camera, it has meant that I have twisted this one. Okay, one's going to be twisted. Let's make sure the rest aren't. So, in theory, that's all we need to do, and we're going to continue doing that for all the rest. And it shouldn't take very long to put all these on. It also should mean that it's relatively easy to pull back off again, and that's really the key part. Is if we do accidentally put the cell on the wrong way, that we want these to be kind of easy to pull back off again. So let's, in fact, I've actually still got this plugged in, so let's just turn that on and see if these lights come on. Okay, so we've got one middle one that the light isn't coming on. So let's just apply a little bit more heat to that. In fact, let's probably turn that off. Maybe we didn't get a good connection somewhere. It's obviously going to be one end or the other. Okay, good. Beautiful. So that looks like all of them, apart from these ones, are working. So that's perfect. In fact, that's exactly what we want. So now we will wire up these last ones here. We'll turn that off since that makes a lot of noise. Now to wire these up, initially I was going to use this buck converter here. Now the problem with this buck converter here is that there's no mounting holes. Now it needs to run 8 amps because there's 1 amp per cell, so 8 cells, 8 amps. This one here should be able to do it, however there's no mounting screws. I found another buck converter I had lying around, this one here. This one here's got some mounting screws, holes on the end, on each of the ends, which is fantastic. So I might actually try and use this one. It actually looks slightly smaller, but it should be able to do 8 amps. The only problem with using these two here is that the terminals are actually not that big. So I should be able to get a couple of wires in there that should be enough to do 8 amps, and we'll just have to give it a go and watch it. Okay, so I've just put in a block here and I've just connected 2 leads for the positive and 2 for the negative from the buck converter, and I've just attached that like that for now, just to make sure that the buck converter is actually going to work rather than using a longer cable or a fatter cable, just because the bottom of the pins in here I can only ever fit 2 of these per socket. So I'm just going to see if one of these types of buck converters will work. Okay, so I've just put the buck converter up there and I just attached a couple of screws. So if I zoom in a little bit, hopefully we'll be able to see, if I move this whole thing over actually, hopefully when I turn it on we should see some blue lights along here, and hopefully that's going to show up in the camera. But let's just have a look, and hopefully they don't just go all pop. I'm pretty sure I've got it around the right way, so we'll find out. Okay, so you can't actually see the blue lights, but you can kind of, if I do that, you'll see it just without moving the camera. So all these now have power. In fact, if I tilt it up, yeah. So that's all good. Lots of blue. All 40 chargers are working. In fact, no, this one's not. So, okay, I might need to put the soldering iron back on that just to make sure that that's okay. So that's the only one that's having some issues. Okay, so this is the finished back for now. I'll tidy this up a little bit later, but they're not going to move around too much. They're pretty solid in there. So I've just cable tied those, got some cable ties there, and this is all not going to move too much. So that's the back of it's looking pretty good. And let's have a look at the front. Okay, so now that that's all working, the last thing I want to do is actually put a little multimeter on, so that way I can, if the cell's not going to charge, I can throw it into a meter and test the cell. Now that's exactly what the amazing charger thing that's been sent around has got on it, and it was absolutely fantastic. I'm going to use just a standalone 18650 holder. I've got this that I've used in other projects, so I'm going to reuse this one. So this is a 100 volt one, which is way more than I need for obviously testing a small cell, but we're going to use this since I've got it lying around. Now I was thinking, well, how am I going to attach that into my piece of wood here and try and keep it nice and neat and tidy? So what I thought about doing was, well, why not print something? So that's exactly what I did. So I printed this bracket that the multimeter will sit straight into, and then that'll be mounted on top of the, oops, there we go, in focus, in camera. That'll be mounted onto the piece of wood. So that way it just slots in and it holds itself up in place. And I'm thinking the best position for this, if I zoom out just a little bit, will be somewhere like up here, and with that there. So something like that. So with that being said, let's kind of attach all that and see if it works. In fact, probably would have been given I'm going to have this on the wall, would have been a good idea to actually have it on an angle like that, but oh well, it's going to be flat. That'll do. Right, so that's how it looks now that the multimeter is in place. So if I turn that off, the cell can be easily taken in and out. I'll put the cell in. Beauty. Now I can check the cells. For example, this one here won't charge. The reason it won't charge is because it's actually sitting at around the 4 volt mark. So that works flawlessly. Charging. And what we've got is, just very quickly, I thought I'd check the current going into the buck converter. So if I pull that out to there, put our clamp, this is the reason I had this the 12 volts out. We've got 4.2, you can't see, 4.25 amps on the 12 volt input to the buck converter. And with any luck, let's try and do this. This is the fun part, eh? Trying to do this with one hand. And not sure if you can see that. We've got 7.8 amps that 5 volts going into those 8 charging boards. So that's pretty successful, I like to say. These cables are, they're just kind of lukewarm, if that. They should be able to easily do 8 amps. So I've added 2 fans here. I created some mounts on the 3D printer just to kind of mount them up. They're sitting about 20 mil off the ground, which means that the flow will be just over the cells. They're not exactly huge blowing fans, but they'll at least blow some air around, and the air should come up to about here, and I'll hopefully push out this way so the fans blow through. And this fan here sucks through the top of the power supply and out the top, and hopefully that'll just pass more air over the heat sinks on this, because this does get a little bit warm. So if there's any blue LED fanboys out there, then this is definitely the charger for you. So tubers, now that that's pretty much finished, first thing we've got to do before we put it back in the garage is do a load test. And what better way to do a load test than a whole pile of red Sanyo 18650 cells. So what we're going to do is we're going to fill the charger up with 18650s. We're going to look at the watt meter, see how much power it's drawing, and we'll also use our temperature thing and figure out how much, or if there's any hot spots, and if things are going to get too hot. If everything's good, then we're good to put in the garage and the project's all done. So let's first have a look and we'll plug in all the cells. Right, so just turning it on, nothing in the cell holders, pretty much just idling. We're using 22 watts. So guys, it's been a good hour and everything's come up to 10. The current watts has dropped down just a couple, down to 247. It was at 252, so it's come back a little bit. But we're about an hour into the charge, and current hotspots are over here. Now, because it's so reflective, it's not exact, it's about 5 degrees off. But yeah, these couple of parts here are slightly warm, and one of the tracks, or the rails at the back, the bus bars at the back, is a little bit warm in the middle, but only around 35 degrees, so it's not bad, but I might improve on that. But either way, everything's looking really good. The temperature of this keeping fairly okay. It's hot to touch, but it's definitely a little bit cooler after having these fans on compared to my first test. So yeah, no, everything's looking really good. So next thing to do is really just tidy it up a little bit more and then stick it up on the wall. So guys, thanks a lot for watching. I'll see you guys in the next video. Comment and subscribe if you haven't already, and yeah, I'll see you guys again soon. Thanks for watching.